Hello, welcome back. All right, now we're going to get into the winery case study. Oh, all right, in part three, we get a winery case study. So we'll jump again a little bit. This is part three of the book, and it's called Case Studies. And the case study number one is called a large winery operation. So if I get thirsty doing this and leave you for a bit, you'll understand why. Just kidding. This is a large winery, pretty good size. There are concerns they have, though, were chemical exposures and bottling, close calls. They've had some releases, complaints, employees, and they're uncertain of the risk. They really weren't sure about this. And so they did the right thing. They weren't sure about it. They got someone who can help them. Nothing wrong with that. Okay, they conducted a risk assessment, identified FSI level exposures and existing controls. FSI is fatality or serious injury. They like to use acronyms in safety, but not everywhere, I guess, anymore. Then they analyzed the risk levels, discussed additional controls. They proposed higher level controls. They had a few controls already, and reassessed the risk. So this is what the consultants did amongst themselves, with the help of they worked together with the management and people with the winery. So this is the risk criteria defined by the winery to be used in the risk assessment. This is the severity level. Get this out of my way here. Severity levels here: low, moderate, high, catastrophic. 4 levels. Likelihood: very likely, likely, possible, likely. 4 levels. So using there you go, 4x4 matrix. That's basically what's just outlining the risk matrix they're going to use, which is fine. Use any risk matrix that they want. And then their action level on the risk criteria is, if it's low, they're going to discretionary remedial action. Moderate remedial action to be taken at appropriate time. High remedial action be given high priority, and immediate unacceptable immediate action required. Operation not permissible except in rare and extraordinary circumstances. So that's the criteria that they've set. Now they identified FSI level exposures using past incidents, chemicals, and materials. Like they have to know what it is, SDS sheets, and that. Review of the process steps, procedures, instructions, job safety analysis, site observations, audits, and brainstorming. And they developed a hazard inventory developed on the next slide. And I kind of like this. This is pretty cool. I think this is not a bad idea. Here you have the different operations: harvest, destem, crush, press, fermentation, clarification, adjustment, aging, bottling, warehouse distribution. This is a winery. Where do they drink it? Oh, well, I guess they don't, huh? They just bottle it and send it out. Oh, well. Anyhow, so you can see that they've identified for each one of these areas uh, of operations the hazards. And this is a pretty simple graph. And if you're a safety professional, you might want to think, let's see, I'm going to get down to the destem crush. Let's see what they have here. They've had some problems with, this type of thing. They could have got this from previous experience, from walkthroughs, whatever. It doesn't matter. But cotton equipment, of course, in the bottling and in the in the crush process, they have machinery. They're obvious. They have forklifts in a lot of different places. Fermentation has a lot of CO2 displacement. So this is kind of a cool little tool here that this wasn't brought up before in this, but I think it's pretty cool. Yeah. So they identified these with associated controls that were already in place. They had some warning alarms. They had some standard operating procedures, and there was some training and chemical use and some PPE. So these were the controls that were already there. So the concern number one, well, they were using pure liquid sulfur dioxide. It's used for dosing tanks inside the buildings, filling and dispensing it. So you got to fill this tank from the big tanks, or fill this tank up in the little tank, right, this tank. Risk or potential for releases during filling and dispensing. Lethal dose 100 parts per million, but the Cal OSHA permissible exposure limit is only 2 parts per million. And the ACGIH TLV is 0.25 parts per million. These people have never, ever, since OSHA's been around, gotten together and figured out what the heck is best here. And that's kind of disturbing. Anyhow, this stuff can cause blindness. There's environmental concerns. They're over the threshold for EPA reporting. Transporting, dispensing, handling, and storage concerns. Anytime you transport anything that's hazardous, that's always a big concern. Or dispense it, handling it. So sulfur dioxide gas is heavier than air and accumulate in closed areas. So that's not a good thing, because if it's heavier in air and it gets released, it's going to stay there. It's going to go down and stay on the ground. And if it's not a well-ventilated area, well-ventilated area, it can be there for a while. If it's lighter than air, it'll obviously rise, but it's easier to ventilate that way. The configuration and lack of ventilation in the bottling area presented a significant risk to employees should a SO2 release occur in the area, because this area is it's not wide open. You can see it there. There's not a whole bunch of, there's probably limited exits. So it's not easy to get out of. So they did a preliminary hazard analysis, and they come up with this: SO2 dosing using 100% SO2 liquid, health risk from leak or release, and they put down the 2 ppm part PEL, 100 ppm lethal dose, heavier than air, that's a problem too. And it's an EPA regulated product, which means it's over the threshold and they have to report to EPA. And that's not a good thing anytime you have to report to the government. So the current severity is 4, and current likelihood is 3, which give them a current risk level of 12. And you can see that's highlighted there. That's because that's a big no-no. 12. That's too high to determine, which is the whole purpose of this thing, to identify that. So here was our recommended controls. Substitute 100% SO2 with 6% liquid SO2 and K2S2O5, potassium metabisulfate, effervescent tablets, granular powder type of thing. So they got rid of the liquid and substituted this stuff. So now the current severity would go down to 2, and the likelihood would down to 2. So now they went down to 4 for their risk, on their risk, from a 12 to a 4. Now I'm gonna move my head over here. Now here, 67% risk reduction. Okay, so where did they get 67%? They took 12 minus 4, which is 8. 8 divided by 12 is 2/3, 67%, 66 2/3%. Exact opposite of what they did in the previous chapter with their risk reduction. So that they were kind of not sleeping that day on their book. So this is actual true. They actually did reduce the risk by a huge amount. It was a 12, went down to a 4. That's fantastic. So this isn't accurate now. 67% risk reduction is an accurate term. Right? So that was a big success. Now they go to concern number 2, DMCD, dimethyl dicarbonate dosing, used to prevent spoilage. It inhibits yeast with half-hour affluent 3 hours, which converts to CO2 and methanol. Highly specialized metering equipment and training operators. So this is kind of the metering equipment here. And it's located in the bottling area. Bottling area, again, has limited ventilation and limited means of escape. So it's not a good place to be if there's a release. The exposure ceiling limit on this is only 0.04 parts per million. Releases have occurred due to operator error and equipment failure. So they've had releases of this stuff. Nobody got hurt, I don't think, but they had releases. They did have to evacuate. So here's their preliminary hazard analysis. Oops, that's the first one. No, it's right. DMDC, metering equipment and bottling area. Health risk to bottling employees from leak or release in area. 0.4 parts per million exposure ceiling limit. They called it 4 current severity and 3 likelihood for a 12. They got a 12 here again. Here's what they did: recommending controls. Eliminate the exposure. Relocate the unit outside the building. The exposure where that unit is, the dispensing unit, and connect it with hose or piping to where they need it, with open ventilation away from bottling area. Continue to follow safety protocols and PPE for the operator. And they got that down to a future severity of 3 and a future likelihood of only 1 now. So they got that down to a 3. And what they call that? They call that 75% reduction. Okay. 12 minus 3 is 9. 9 divided by 12, 0.75, 75%. That's accurate. So they really did come up with this. I mean, it's good if you can eliminate the exposure. They eliminate the exposure in the building. They have it outside, but they did eliminate it in that area. Being outside is a way less hazardous. So that was a good outcome there too. All right, let me get back up there and get the show road. So there you go. They eliminated 2 FSI risks as a result of this, in the SO2 and the DMDC. And This was a really successful operation. I don't know how it took them or anything like that, but they did it. So the case study, the results of this whole thing, they removed 2 fatal or serious incident level risks, 66 risk reduction in SO2 exposure to employees in the community, 75 risk reduction for DMDC exposure risk, improved employee morale. And when you do something like this, it only does usually improves employee morale. And that's not to be taken lightly. That's an important factor. Eliminated EPA reporting requirements for SO2. That's a big thing too. You don't ever want to be telling the government anything if you can help it. Now, if you have to do it, you do it, of course. If it's a law, you don't want to disobey the law. But if you can legally get out of it, well, that's what you want to do. Low cost for K2S2O5 effervescent tablets and ease of use. Low cost to relocate and shelter the DMDC metering machine outside. So they did some things that weren't that sophisticated or difficult and reduced the hazard, the risk quite a lot. The sequence of methods used in a risk assessment. This is which go over it. Identification, your documents, checklist, survey, interviews, brainstorming, and you get the hazards. You have to identify the hazards. Preliminary hazard analysis, FMEA, hazards, causes, severity. That's a failure mode effect analysis. Hierarchy of controls, of course, bow tie analysis. They didn't do that here. I don't know why they put that in here. And simple risks you can cut right down to here. Okay. Risk assessment matrix, which is basically a risk matrix. Cost benefit analysis. Whoops. And boo-boo. Cost benefit. I'm supposed to click on that. Cost benefit analysis, risk levels, and action matrix. Okay. Risk assessment. They're just prioritizing there. And prioritize to communicate risk and monitor and review. So that was pretty cut and dry, pretty simple operation. So, but with a lot of success. But they went out, they knew they had problems, and they also didn't know how to handle them. So they got some help in there, and it was very successful. So don't ever be afraid to get in and bring in some help. And in the meantime, you know what I'm going to ask you. Be safe.